In this video, I'm going to talk you through the answers to the Edexcel IGCSE higher tier paper from the 15th of January 2020. But please note, this is the R paper. It was the paper sat in the regions, so not in the UK. This video has reference 8R. If you want to see the paper from the same date that was sat in the UK, you need to look up my reference 8. Question number 1. Well, this is just one of the basic index laws. When we multiply, we add the powers. 17 add 2 is 19, so 5 to the power of 19. Now, product of prime factors, you want to do one of these number trees. So start off with the 800 and think of any two whole numbers that multiply to be 800. You could do any you want. You could do 402, for example. I've done 80 and 10. I can then keep on breaking these down. So 80 becomes 10 times 8, the 10 becomes 2 times 5. Now 2 and 5 are both prime numbers, so put circles around those. We've finished with those. The 10 becomes 2 times 5, and again they're both prime, put circles around it. The 8 is 2 times 4, and we can further break down the 4 into 2 times 2. So gathering all of these up, we can see that 2's appearing 1, 2, 3, 4, 5 times, and the 5's appearing twice. So put it in numerical order. You must remember to put in the multiplication signs between them all, okay? It's the product. Product means timesing them together. And if you were to times these all together, you get back to where you started, which is 800. Question number 2. Now here we're being asked to work out an estimate for the total amount of money that Fiona spent in the year. So we know that on 5 occasions, 5 weeks, she spent between nothing and £20, but we don't know how much she actually spent. So this is where the estimating comes into play. We just have to go down the middle and take the midpoint. So halfway between 0 and 20 is 10. Similarly, in this second row, on 11 weeks, she spent between 20 and £40. We don't know how much, so we go straight down the middle, which is 30. So we get these midpoints, these estimates here, and from the rest of the question, we just assume that's exactly how much she spent in those weeks. So in this first row, we're just estimating that on 5 occasions she spent exactly £10. On 11 occasions she spent exactly 30. So adding up all that money spent, well, 5 times she spent £10, 5 tens are 50. On 11 occasions she spent £30, 11 times 30 is 330, and so on. So carry on doing this cross multiplying, giving you these subtotals here, then add all of that up, and that's 2920. Now that has to be your final answer. Do not be tempted to round this to say 2,900 or 3,000. Okay, when they're referring to estimating, that's to do with this initial assumption we made here. They do not want you rounding your final answer. Question 3, well, we're told that tin A contains X buttons. Tin B has 4 times as many as tin A, so that's 4 lots of X, 4X. And tin C has 7 fewer than tin A, so 7 fewer than X, so that's X minus 7. Now we're then told that all of these buttons in the 3 tins add up to 137. So X plus 4X plus X minus 7 must total 137. So over here we just construct that equation. Okay, X plus 4X plus X minus 7 equals 137. So we've constructed an equation, we've just got to now go and solve it. So simplify the left-hand side. X plus 4X plus X is 6X. So 6X minus 7 equals 137. How do we undo subtracting by 7? We add 7 to both sides. So 6X equals 144. 137 add 7. How do we undo timesing by 6? We divide by 6. So X equals 144 divided by 6, which is 24. Now that's what X is. But we're being asked to work out the number of buttons in tin C. Now tin C has whatever X is, take away 7. So tin C has got 24 being X, take away 7. 24 take away 7 is 17. Question 4, we're just being asked to work out the length of the diagonal of the rectangle. So just really ignore this part of the rectangle. We've got a right angle triangle here, where the smaller sides are 8.5 and 5.6, and we're trying to work out the length of the hypotenuse. So using Pythagoras, x squared equals 8.5 squared plus 5.6 squared. Popping that into a calculator, we get 103.61. How do we undo a squaring? We square root. The square root of 103.61 is 10.1788 ... which to one decimal place is 10.2. Question 5 was speed is distance divided by time. So the only really tricky bit here is converting 3 hours into 30 and 36 minutes into a number of hours. Now, obviously, there are 60 minutes in an hour. So the proportion of an hour that 36 minutes is 36 out of 60. So 3 hours 36 minutes is 3 and 36/60ths of an hour. Now popping this into your calculator, that's 0.6. So this is 3.6 of an hour. So speed is distance over time. The distance is 2470 kilometers. The time is 3.6 hours. So all our units are right. We wanted it in kilometers and hours. Pop this into your calculator, you get 686.111. So to the nearest whole number, that is 686. Question 6. Now, I'm afraid I don't have the software to draw the compass arcs accurately, so excuse these blue lines being a bit wobbly. So in order to do this, you've got to use a compass and ruler, and you're just using the ruler for drawing a straight edge. You're not using it to measure a length. So step 1, go and get your compass, put the pin at A and get a length, the radius of the compass, which is most of the way along, but not all of the way along, and then just do a nice big arc. Okay, so if we say starting off doing it from B, actually, if we do it from B first of all, that would be my first workings there, which I've called workings 1. Now, keeping the same radius on the compass, so don't adjust the distance between the pencil tip and the pin. Now go and put the pin at A and draw another big arc, which I've labelled step 2. Now your final answer is then the straight line going through where these two arcs cross here and here, which I've labelled 3. So the red line is my final answer, but you must leave your construction arcs in to demonstrate your workings. Question 7. Now we can see here that the numerical values of y are both 5. So we've already got one of the variables lined up. We don't have to do any multiplying to start with to line the variables up. Now, what we're going to choose to do is either add these equations together or subtract them with the goal that we're trying to eliminate one of the variables. Now, because the y's are both 5, but the signs are different, if we choose to add these two equations together, the y's will disappear, which is what we want. Because 5y added together with minus 5y is 0. So step 1, make the right decision on whether to add or subtract the equations. So we're going to add them. 3x adds 7x is 10x. 5y added together with minus 5y is 0, which is the whole point. And 6 added together with minus 11 is 6. Take away 11, which is minus 5. So 10x equals minus 5, which is obviously solvable. How do we undo timesing by 10? We divide by 10. So x is minus 5 over 10, which is minus 0.5. So we're halfway there. Now, to find y, we substitute this value for x back into either of the two original equations, and I've chosen to substitute it into the first one, 3x plus 5y equals 6. So we know x is minus 0.5, so here it is. 3 lots of minus 0.5 is minus 1.5, add 5y is 6. Add 1.5 to both sides to undo this minus 1.5. We get 5y equaling 7.5. Divide by 5, we get y being 7.5 over 5, which is 1.5. Question 8. Now, when a car depreciates by 19% each year, it loses 19% of its value each year. So we're taking away 19% of what we started with each year. So 100% take away 19% is 81%. Dividing this by 100, this gives us a multiplier of 0.81. So we can go straight into a calculation to go straight to final answer. We start off with our principal value, which is at $20,000. We multiply by the multiplier, which I just described, but this is to the power of the number of years. And the number of years is 3. So popping this into your calculator, you get 10,628.82. So to the nearest dollar, that is 10,629. Question 9. Now we're told that pressure equals force over area, and the area is the area that's coming into contact with the ground, the table. Okay, so the area of the base of this cuboid is 1.2 times x. So pressure equals force over area. Well, we're told the pressure is 30. We're told the force is 27. And the area is 1.2 times x, so that's 1.2x. So again, we've just got an equation to solve. Okay, we've constructed an equation, we just now need to solve it. So how do we undo dividing by 1.2x? Let's multiply by 1.2x. So 1.2x times 30 equals 27. 1.2 times 30 is 36. So 36x equals 27. How to undo timesing by 36? Divide by 36. So x equals 27 over 36, which is 0.75 meters. Question 10. So for part A, we're being asked to work out the difference in square kilometres between the surface area in the Atlantic, which is 1.06 times 10 to the 8, and the Indian Ocean, 6.86 times 10 to the 7. So just simply put this into your calculator to work it out. I would use the times 10 to the x button, the one that is right at the bottom of the middle of most calculators. Anyway, popping that into your calculator, I get my answer in normal format. So this 374 followed by 5 zeros. Now the question requires me to give my answer in standard form. So remember how this works. Step 1, your opening number's got to be between 1 and 10. So where would the decimal point go to make the first number between 1 and 10? Well, between the 3 and the 7, giving us 3.74. Right, step 2, write down times 10 to the power of something, so times 10. And the power is going to be a positive number because this is a big number. So to get the power, we've got to consider the number of hops that the decimal point makes. So it's starting off at the end of the number, and it's got to end up between the 3 and the 7. So just considering the hops the decimal point makes, 1, 2, 3, 4, 5, 6, 7 hops. So 3.74 times 10 to the 7. Now, for part B, we're being asked to work out how many times bigger the Pacific Ocean is compared to the Arctic Ocean. So we've got to do Pacific divided by Arctic. Now, Pacific is 1.56 times 10 to the 8, and Arctic is 1.41 times 10 to the 7. So popping this into your calculator, and again, I would definitely use the fractions button, which is normally the third one down on the left of calculators. That gives me 11.06 dot dot dot. So to the nearest whole number, that's 11. Question 11. So reading from the center, we want all the integers, that's whole numbers that are greater than -2, but at the same time are less than or equal to 4. So that's -1, 0, 1, 2, 3, 4. Now for part 2, they've given us all the lines, so could just consider those like fences around a field. And we've just got to write down which side of these fences our region R is. So one thing to note, all these lines are solid lines. They're not dotted, so all our answers are going to include equal signs. So taking these in turn, x plus y equaling 5. Well, we're above that. So x plus y is greater than or equal to 5. Considering y equals 6, well, our region is below that. So y is less than or equal to 6. And then considering y equals x minus 3, well, we're above that one. So that's y is greater than or equal to x minus 3. Question 12. Well, quite a bit of work to do here. First thing to take on board is these two grey triangles or isosceles triangles. So the base angles are equal, which in fact they've already told us. So to work out this angle here, this angle ABC, well, angles in a triangle add up to 180. So this angle ABC and the angle DEF are just 180, take away 2 lots of 66, which are 48. So that's the angle in blue. Now, secondly, I've worked out this angle here going from here to here, which is going to be the same as going here to here because of the symmetry. Now, angles about a point add up to 360. So if we do 360 take away 48, that gives us this total angle around here, which is split equally above and below the line. So halving that, we get this angle here to be 156. Now, considering, I mean, it doesn't matter which one we do, but let's just think of it from polygon Y point of view. That angle CBE, its interior angle is 156. Now, consider just extending that line from E to B, carrying on horizontally, which I've done here in red. This angle from here round to the horizontal, okay? Obviously, angles on a straight line add up to 180. So this little angle here in red is going to be 180 take away 156, which is 24. Now that's the exterior angle of this polygon. Now exterior angles of regular polygons always add up to 360. Now I've just worked out that one of them is 24. So how many of them are there going to be given they all add up to 360? When you do 360 divided by 24, giving you 15 exterior angles or 15 sides. Question 13. Now we're told the volume of this prism is 608. So therefore we can work out the area of the face ABCD because the volume of any prism is the area of the cross section ABCD multiplied by the depth of the prism. So we've got the area ABCD is going to be 608, the volume divided by 10 being 60.8. So just going over that again, this area of the cross section ABCD is 60.8, times that by 10 to get the volume, we get 608. So we can now just consider the trapezium ABCD, of which we know the area is 60.8. Now, the area of a prism is worked out by averaging the two parallel sides and then multiplying that by the distance between them. So averaging the 7 and the 12, how do you average two numbers? You add them together and divide by 2. And this multiplied by the distance between them, h, is going to give us my area of 60.8. So another question where I've gone and constructed an equation which I can solve. Now 7 add 12 divided by 2 is 9.5. So 9.5 h equals 60.8. To make h the subject, divide both sides by 9.5, giving us 6.4 centimetres. Question 14. Now, to work out the interquartile range, first of all, we're going to have to put these in order, smallest to biggest. Now, really take your time here. It's ever so easy to miss one out. So I've just carefully gone along, crossing them out as I went, giving me this row of numbers here. Now, the first thing you do is you take the middle number, and that's going to be the sixth one along. That's my 14. And that then leaves me two sides, either side of the 14 with 5 numbers. And then I take the middle ones of those 5. So that's 11 here, 2 numbers either side, and the 17 here, 2 numbers either side. In my interquartile range, the difference between these two numbers, 17 take away 11 is 6. Question 15. Now, I think with these, it's always handy to appreciate what your shape of your graph is going to be before you begin. Now, this is a quadratic, so it's either going to be a positive or negative parabola, so either a happy or sad face. And because it's an x squared, a positive x squared, it's going to be a happy face graph, a positive parabola. So this shape is going to be what we're ending up with. And just make sure that you do a nice curvy line and keep the base curvy as well. Don't have any flat edges. So sometimes we can rely on symmetry between the y values just to fill it in, but you can't here. We're going to have to work each of them out in turn. So I'm going to start off when x equals 2. Okay, take my 2 and substitute it into the formula. So 2 squared minus 2 over 2 minus 3, and that gave me 0. So my first coordinate is 2, 0. Then in red, I'm substituting in x being 0. So 0 in here, 0, take away 0, take away 3 is minus 3. Then I'm going to substitute minus 1 into the formula, which I've done here in purple. Now be ever so careful here. When you've got negatives, make sure you protect the minus by putting it in brackets, right? Your calculator, if you just did minus 1 squared, would say minus 1, which is wrong. You've got to put it in a bracket. So open bracket minus 1 close bracket squared will give you the correct value of 2. So always protect the minuses, and similarly I've done that here in black. So anyway, when I substitute x in being minus 1 into this, I get minus 5. And when I substitute minus 2 into this, I get plus 2. So I then plot these coordinates for part B. So I've plotted minus 3, 7.5. So minus 3 along the corridor, up the stairs, and so on. So I've plotted the 1, 2, 3, 4, 5, 6, 7 coordinates here, and then a nice gentle curvy line done in pencil, please. Question 16, part A. So we've just got to fill in the probabilities. Now with bag A, because odd numbers is 7 out of 10, Even numbers has got to be the rest. It's going to be 3 out of 10. These crocodile mouth, if you like, always add up to a whole. Now in bag B, we're told that 7 of the 12 are odd. So the probability of an odd is 7 out of 12. Probability of an even is 5 out of 12. And those are repeated down here. Now, we're being asked to, for part B to calculate the probability that the total number, when you add them together, will be odd. So consider how you can end up with an odd number. If we got an odd first of all and then an odd with the second from the second bag, odd plus odd is even, so we don't want that. Even plus even is even. But the two ways we can end up with an odd when you add them together is you get an odd from bag A and an even from bag B, or an even from bag A and an odd from bag B. So these two options are what I've done here in yellow and orange. So odd, even, and also even, odd. Okay, so working those out, we're obviously on the yellow journey. We've gone past the 7 over 10 and the 5 over 12. So we need an odd and then an even. Now, when it's and, you multiply. So 7 over 10 times 5 over 12 is 35 over 120. And similarly with the purple root, the orange root, we need an even and then an odd. So 3 over 10 times 7 over 12, done here in orange, which is 21 over 120. Now, I don't care which of these two roots I take, be it the yellow root or the orange root. So it's either this one or this one. And then when it's an or, you add them together. So adding these two together, we get 56 over 120, which you could have simplified if you wanted to, but you didn't have to. Now, for part C, we're being told the probability that we get that Cody got two evens, but then also that Harriet gets an even as well, equals 3 over 100. Okay, so that Cody had the two evens from part B above, and then Harriet comes along and also gets an even, equaling 3 over 100. So probability of even, even is 3 over 100. Now, looking back to our tree diagram from part A, we can see for Cody the probability of an even and then another even is 3 over 10 times 5 over 12. And then multiplying that by the unknown probability that Harriet gets an even, we get 3 over 100. So yet another example on this paper where we've constructed an equation that we have to solve. So just pop it into your calculator. 3 over 10 times 5 over 12 is 0.125. And obviously 3 over 100 is 0.03. So divide both sides by 0.125 and we get the probability of Harriet getting ahead being 6 over 25. Now think about it. That can't be simplified. So in order to get a whole number on top, the probability, the numerator has to be a whole number. We're going to have a minimum of 25 balls in Harriet's counters in Harriet's bag. Okay, so just think about it. Anything less than 25, this is the fraction. This is the probability. So it could be 60 over 250, or it could be 12 over 50. We don't exactly know, but given we're trying to work out the least number of counters, we can't simplify this any smaller. So there must be at least 25 counters in the bag in order to give us this probability, this ratio of 6 to 25 or above. Question 17. Now, the secret with these is to always start with the numbers nearer the middle of the Venn diagram. So start off at near the bottom of the list. So I've kicked off with number 1. There's 6 have a dog, a cat, and a rabbit. So that's gone into the middle. Number 2, 5 haven't got any of them. 5 have not got a dog or a cat or a rabbit. So there's my 5 there. That was easy. Now, 3, got to start thinking now. X have both a dog and a cat. Now, the dog and the cat region is this bit here. So, in order for that to be X overall, given that bit there is 6, this bit here has got to be X minus 6. Because X minus 6 plus 6 is X, and that's what we need it to be. X have both a dog and a cat. So that was tricky. Right, the next bits aren't quite so bad. Number 4, 9 have both a dog and a rabbit. So dog and a rabbit is here. Okay, so 9 have both a dog and a rabbit. Dog and a rabbit's got to be, so that's this bit here. This is dog and a rabbit. We've already got the 6 here. So this must be 3 to make this region here 9 overall. Right. Point 5. 8 have a cat and a rabbit. Now this is the cat and the rabbit area. That's got to add up to 8. Well, I've already got the 6 here, so that has to be 2. Right, 5th point. 20 have a rabbit. Okay, so the rabbit is the whole of this football here. Okay, 20 have a rabbit. I've already got my 3, 6, and 2. So 20 take away 3, 6, and 2 gives me this 9 here. Now, the tricky 2. 18 have a cat. So the whole of this cat football here has to add up to 18. So these regions here, 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 and here together have to add up to 18. So 18, take away these 3 I've got already, will give me this one here. So 18 take away the 3 I've got already. So 18 take away this. This simplifies to x plus 2. 18 take away x, take away 2 is 16 minus x. Then finally, 28 have a dog. So the whole of this dog football has to add up to 28. So 28 take away this, this, and this gives me this area here, which I've processed over here, which is 25 minus x. Now, for part B, I'm told that the total number of students is 50. So all of these numbers in the Venn diagram have to add up to 50. So again, we're just constructing a huge equation. This plus 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 this has to equal 50. So I've set that out there, simplified the left-hand side here, added x to both sides, taken away 50, and I get x being 10. Now, for part C, I'm trying to find the number which are both not in C, but also not in D. And that's just these 2 here. Everything else is either in C or in D. This means not C and also not D. So 9 and 5 is 14. Question 18. So this is one of those 2 extra circle theories you need to learn for IGCSE involving lengths, not involving angles. So basically you've got to learn that that length from C to P multiplied by that length from P to D equals the length from A to P multiplied by the length from P to B. So yellow times yellow equals orange times orange. So 8 times P equals 9 times 6. So 8P equals 54. Divide by 8, 54 divided by 8 is 6.75. Question 19, part A. So I really want to undo this dividing by 5 and dividing by 2. So I can undo both of these if I choose to multiply each component by 5 2s are 10. So I'm going to multiply this by 10, this by 10, and this by 10. So I've just popped the 10 here, here, and here. Right, now 10 divided by 5 is 2, so this is 2 lots of 4 minus 3x. 10 divided by 2 is 5, so that's 5 lots of 3x minus 5. And I've now got sort of a single tiered equation to solve. So I then do the claw, 2 times 4, 2 times minus 3x, minus 5 times 3x, and minus 5 times minus 5 to give me this line here. I've then gathered up all my x's and my normal numbers on the left, so minus 21x plus 33 equaling minus 33. I've added 21x and added 30 to both sides, giving me 21x is 63. Dividing by 21, I get x equaling 3. Part B, I'm going to turn this into a quadratic to solve by taking away 40 from both sides, so it's less than or equal to 0. And I'm then factorising this. So what 2 magic numbers multiply to be 5 times minus 40, which is minus 200, but add to be the coefficient of y, which is minus 17. Well, that's minus 25 and 8. So my second line of workings, I'm just breaking down this minus 17y into minus 25y and plus 8y. Doesn't matter which way around. So as I go from this line to this line, I've gone from there being 3 terms on the left to 4 terms on the left. I now fully factorise terms 1 and 2, so I'm taking out the 5y, and I've fully factorised terms 3 and 4, giving me 8y minus 5. And note how I made sure this was a plus 8 so that I got a repeated bracket. And then my final line here, my two brackets are the components outside the brackets, so the 5y plus 8 and the repeated bracket. Now, from this, I can see my roots, if it was equal to 0, are minus 8 over 5. That would make this bracket 0 and 5. So help me gather my thoughts. I'm just going to do a little sketch. So this is a positive quadratic, so it's a positive parabola. And my roots are at minus 8 over 5 and 5. And I'm looking for all the solutions that are less than 0, so the set of solutions below the x-axis. And as it's one set of points, I do this as one inequality. So x is less than or equal to 5, or greater than or equal to minus 8 over 5, which is minus 1.6. Question 20. So we're told the length ratio between A and B is 9 to 13. 9 to 13. Now the ratio of length is one-dimensional. For the area ratio, which is two-dimensional, you need to square the length ratio. So 9 squared is 81 and 13 squared is 169. So the ratio of the areas of A and B is 81 to 169. Adding those together, that gives us a total ratio share of 250. Now we're told the actual total area is 1,800, so I pop that in the total column. So how do I go from the ratio to the actual values? What do I multiply 250 by to get 1,800? Well, I've done 1,800 divided by 250 to find that my multiplier is 7.2. Now I'm being asked to work out the surface area of vase A, so I take my 81 and multiply that by 7.2, giving me 583.2. Question 21, part A. So I need to factorise the numerator and the denominator. So I factorise the numerator over here on the right. So how do you factorise a quadratic where the coefficient of x squared is not 1? So step 1, what two magic numbers multiply to be the 10 times the 12, which is 120, but at the same time add to be the coefficient of x, which is 23? And that is 15 and 8. So my second line of workings, I go from 3 terms to 4 terms. I split the 23x down into 15x and 8x. It doesn't matter which way around. So I've got 4 terms here. You then fully factorise terms 1 and 2, which I've done here. And then you fully factorise terms 3 and 4, which I've done here. And just make sure that you choose the right sign here to get a repeated bracket. And then your final pair of brackets are the two components not in the bracket, the 5x plus 4, and the repeated bracket. So that's my numerator. Now with the denominator, you've just got to spot that this is a difference between two squares. You've got a square number, take away a square number. So this is 2x plus 3, 2x minus 3. I've written it 2x minus 3, 2x plus 3, because these are going to cancel in a minute. Okay, so you're going to, if this is going to simplify, you're looking out for there to be a common bracket in the top and the bottom, which you can cancel out. So if you don't get that, perhaps go back and check your calculations. So I've got a 2x plus 3 and a 2x plus 3, so they cancel. So my final answer is 5x plus 4 over 2x minus 3, and I no longer need the brackets. Part B. Now I want to have a common big number here, so which is always going to be the smallest number. So I've got a 2 here, a 2 here. So I want to turn this 8 into 2 to the power of something. Well, 8 is 2 to the power of 3. And I turn the 4 into 2 to the power of 2. So here I'm just, on the right-hand side, I'm just rewriting the right-hand side with the base being being 2. Now on the left-hand side, I've just taken the opportunity to follow the index law. When you multiply, you add the powers. So 2y plus 3y plus 2 is 5y plus 2. Now, going from here to here, if you've got a power inside and outside the bracket, you multiply them together. So 3 lots of 5y is 15y, 2 times n is 2n. And then following the index law again, when you're dividing, you subtract the powers. So this becomes 2 to the power of 15y minus 2n. So I've now got 2 to the power of stuff equaling 2 to the power of stuff. So these two powers now equal each other. So I can just isolate these powers. So 5y plus 2 must equal 15y minus 2n. And this is just a simple linear equation to solve. So gather up your y's, gather up your n's, and I get and make n the subject because we're being asked to find an expression for n in terms of y. So making n the subject. So I've gathering this up, I get 2n equals 10y minus 2, halving everything, n equals 5y minus 1. Question 22. So the first term of the arithmetic series is minus 6, so a equals minus 6. The sum of the first 30 terms is 2865, so the sum of the first 30 terms is 2865, and they've got 30 terms, so n equals 30. So substituting these three facts into the given formula at the front of the exam, I can work out what d is. So I've just substituted in here, processed the algebra, and I get d being 7. So now that I know a and d, I can go and work out any particular term I want. So for a specific term, I think to remember the formula for specific terms, remember this is summing terms. This would say give you the sum of the first 9 terms, for example, but we don't want to add the first 9 terms, we just want the specific 9th term. So just remind yourself how an arithmetic series works. So the first term is a, then we add on the common difference, so our second term would be a plus d, then a plus 2d, and so on. And this is the first term, n being 1, n being 2, the second term, n being 3. And note the difference between the number of d's and the term number. So the number of d's is always one less than which term it is. So for the 9th term, when n is 9, we need to work out a plus 8d. So a is minus 6 from the question. We've just worked out d is 7. Substituting that in, we find that the 9th term is 50. Question 23. Well, here I'm going to have to complete the square. So I've started off just by writing it in the more common format. So my x squareds first, then my x's, then my normal number. Now, in order to complete the square, you need to have a single x squared. So I've factorized taking out the minus 2. So just check you're okay with that. Minus 2 times that is this. Minus 2 times 6x is minus 2x. Minus 2 times minus 7 over 2 gives me my plus 7. So I can now just complete the square on inside the square bracket. So remember what you need to do. You need to halve the coefficient of x, which is 6. So half of 6 is 3. So x plus 3 all squared is my starting point. When you do x plus 3 times x plus 3, you get x squared plus 6x plus 9. Well, I don't want the plus 9. I just want the x squared plus 6x. So I back out that fourth claw. That's why I've got the minus 9 there. So just make sure you're comfortable that all of that there, the x plus 3 squared minus 9, equates to x squared plus 6x. And then I've still got my minus 7 2 on the end. 7 over 2. Right, just gathering up the minus 9 and the minus 7 over 2, I get minus 25 over 2. And then finally, I can just multiply each of these terms by minus 2. So don't overcomplicate things. Leave this as it is, but just say it's minus 2 lots of that. So minus 2 times the bracket, and then minus 2 times minus 25 over 2 is plus 25. And then for my final answer, I've just followed the format they wanted me to put down. They wanted the number first. So it's 25 minus 2 lots of x plus 3 all squared. Question 24. So there's a lot going on here. Now I'm going to start off by looking at line 1, L1. Now I've told that 5x plus 10y equals 8. So taking away 5x from both sides, I get 10y equaling minus 5x plus 8. Dividing by 10, I get y equaling minus a half x plus 4 over 5. So my gradient of line 1 is minus a half. So therefore, my gradient of line 2, which is perpendicular, you flip the minus a half over and change the sign. So it becomes minus 2 over 1, change the sign, it becomes 2 over 1, which is 2. So I know my gradient of line 2. I've also been told a coordinate on my line 2, 8, 6. So using the y minus y1 formula here, I can substitute in my m being 2, my x1 being 8, and my y1 being 6. Processing this, I get the formula for L2 being y equals 2x minus 10. Now I'm going to find the coordinates of point A and point B, both which are to do with line 2. So I'm told that line 2 crosses the x-axis at the point A. Now it crosses the x-axis when the y-coordinate is 0. So substitute y equals 0 into the equation of line 2. So y being 0, so 0 equals 2x minus 10, so x equals 5. So my coordinate for A is 5, 0. Now, secondly, I'm told line 2 intersects the line x equals minus 3 at the point B. So x equals minus 3. So substitute in minus 3 into your line 2. So y equals 2 lots of minus 3 minus 10. So our y coordinate is minus 16. So B is minus 3 minus 16. Right, now in order to find the area of triangle AOB, I'm just going to do a little sketch to help me gather my thoughts. So obviously O is the origin, A is 5, 0, and B is minus 3 minus 16. Now, remember, you can work out the area of a triangle like this by doing base, which is my 0 to A, times the perpendicular height. So that's the height straight up from B to the x-axis. So that height is 16, because we're going from minus 16 to 0. This length is 5, because we're going from 0 to 5. So the area of triangle AOB is half times base times vertical height, half times 5 times 16, which is 40. Question 25. So let's start off by working out a squared minus b squared, with a being n plus 1 and b being n minus 1. So a squared minus b squared will be n plus 1 all squared minus n minus 1 all squared. Now n plus 1 squared is all squared is obviously n plus 1 times n plus 1, which is n squared plus 2n plus 1. And n minus 1 all squared is n minus 1 times n minus 1, which is n squared minus 2n plus 1. Now be careful, this is going to be minus n squared plus 2n and minus 1, okay, because we're effectively multiplying by minus 1. So that gives us this. The n squareds cancel and the 1's cancel, leaving us with 2n plus 2n, which is 4n. So we've shown that a squared minus b squared is 4n. Now we're told that n is a multiple of 5, so it's 5 times something, so let's call it 5 times x. Now we've just worked out that a squared minus b squared is 4n, but n equals 4x, so therefore a squared minus b squared equals 20x. So therefore, given it's being multiplied by 20, a squared minus b squared is always a multiple of 20. Question 26. Now, these vector questions like this are really difficult, okay? So, in short, what we're going to try and do, we've got to write the vector from O to N in terms of A and B. So in order to do that, we're going to have to go from O to N 2 different ways using all the information given in the question. So incorporating the 3A, the 4B, and the 6B. So I'm going to start off by going from O to N via the orange route. Okay, so O to N via A. Now what I know is that O to N is part of O to C, or it's obviously on the same line. So it's a fraction of OC. So I'm going to say ON equals lambda OC. So lambda is going to be some decimal, isn't it? It's going to be some part of OC. Now what is OC? Now O to C is O to A plus A to C, which is 3A plus 4B. Now, this is the key bit, really. You've now got to rearrange this so you've got so many A's and so many B's. So just rewriting this, 3A lambda as 3 lambda A, and lambda times 4B as 4 lambda B. And I'm going to park this now. So it's so many A's and so many B's when I go via A. Now, secondly, I'm going to go again from O to N, but this time via B. So I'm going to do the green route. So it's going to be OB plus B to N, where B to N is a fraction of B to A. Okay, obviously B to N is on the same line as B to A. Okay, so O to B plus B to N is the route I'm going to take. And as I said, that B to N is a fraction of B to A, and I'm going to call that beta. That's the fraction along there. Bn is compared to Ba. So O to B is obviously 6B. Now B to A is when I go from B to O and then O to A, okay, which is going to be a minus 6B plus 3A. Minus 6B plus 3A. So O to B is 6B, B to A is minus 6B, going along that the wrong way, and then up O to A the correct way, 3A. Multiplying out the brackets, I get minus 6B to B plus 3B to A. And gathering like terms, I get this. And again, what I've done, I've got so many A's and so many B's. So it's 3 beta lots of A and 6 minus 6 beta lots of B. Okay, so I've now gone from O to N two completely different ways, with this answer here and this answer here being two different versions of O to N. So these are both equal to each other. So this number of A's and this number of B's must equal this number of A's and this number of B's. So I can now do what's called equating coefficients. So looking at the coefficients of A, that 3 lambda must equal that 3 beta. So obviously dividing by 3, lambda must equal beta. So I've concluded that from comparing the coefficients of A. Now let's move on to the red bit. Let's compare the coefficients of B. So 4 lambda must equal 6 minus 6 beta. Okay, 4 lambda, coefficient of B equaling coefficient of B. Now subbing 1 into 2, so this into this, I get 4 beta equals 6 minus 6 beta. Solving that, I can get that both beta and lambda are 3/5. So now that I know that beta and lambda are 3/5, I can now go on and work out what ON is by substituting my knowledge of beta and lambda into either this equation here or this equation here. I'm going to substitute it into this one here. So 3 lambda lots of A plus 4 lambdas lots of B. So here I'm just copying out over here. So subbing in lambda being 3/5, I get ON being 9/5, not A plus 12/5 B. In other words, 1.8A plus 2.4B. And that's my final answer.